Automated tests are one of the most effective ways to be confident that when developing software, your code actually works as expected. Testing your code is instrumental to improve code quality, reduce bugs, increase confidence in your code, automate regression testing, and refactoring your code. Hey friends, welcome back to the channel. If you're new here, my name is James. I'm a software developer based in the UK, and on this channel, we explore the strategies and tools that help junior developers evolve their careers. In this video, we'll be covering the basics of testing using Visual Studio, .NET 5, and a testing framework. I'll go through why you need testing, how to write your tests, advantages and disadvantages, and demonstrate how I write tests. And by the end of this video, you'll have some grounding to be able to learn more advanced topics in testing. So why is testing beneficial? The reason why we would want to test our code is to ensure that our code works under varying circumstances with different inputs. Depending on the program you write, your user may not enter inputs that you would normally expect. And so knowing how your code will behave when this happens is good to know, and whether that behavior is expected or even acceptable. Testing also improves the quality of your code. You'll find that when you have tests in place, the quality of your code will improve. This could be due to being certain that the behavior of your code is working correctly, therefore giving you confidence to alter and improve it without breaking the underlying logic or functionality. It also helps you focus on quality because you're having to think about all of the scenarios you need to test. It may even highlight that there are areas in your implementation which needs to be addressed, such as error handling or failing gracefully, in order to keep the user experience of your application smooth. An advantage of testing is that once the tests are written and passing, they are very repeatable, meaning you can run them as frequently as you want, and they should succeed every time. And if at any point during the development cycle, some tests are failing, it's likely due to any updates or edits made to the code base since. How to test my code? Basically, it is you writing methods to test other methods in your code base. These are often written in a test project or within its own directory. You arrange the environment or scenario, which will include preparing your code to be invoked by the test method and then asserting what outcome you are expecting. Each test, ideally, will cover a scenario within your code. This includes if-else statements, cases, loops. Anywhere there's logic and has some functionality should have tests to cover those lines of code to minimize or remove any unexpected behavior your code may encounter. Advantages. The benefits of doing all of this is that you can perform what's called a regression test, meaning if you make updates to your code, running your tests again will inform you whether the functionality is still intact, despite any updates you've just made. Bear in mind that regression testing is not exclusive to automated tests. Some companies have QA departments to do manual regression testing for their products, but understandably, automated tests ran by the code base will not only be faster, but is repeatable, consistent, and less prone to human error or oversight. You can also automate the setup and teardown of each test to make sure the scenario and environment is the same every time. Tests can also be treated as documentation for any developer who maintains the source code. Some projects are large, and it is unlikely that any one developer will remember every piece of logic that is written. So well-written tests with good titles can be used to document business logic and other functionality. There are some downsides, however. It requires more time up front. Not only does the developer have to write the functionality, but the tests as well. Tests need to be thorough, and covering all of the edge cases will take time. The second disadvantage is that the tests are only as good as the developer who writes the tests. If the tests are poorly written or not thorough, then relying on those without any other regression tests increases risk. If your tests are brittle, then they can also require time to fix those tests whenever you add logic, even though the actual functionality hasn't actually been altered. It's harder to test UI with these tests, so having a QA team or the developer manually check the UI is still required. So to demonstrate testing, I'll have here a date helper class. And this date helper class has a isPublicHoliday method, which accepts a date parameter. The purpose of this method is to receive this date parameter and determine whether it's a public holiday or not. So as an example, if the date is on January and the day is the 1st, we return true. If the date is on May and is the first Monday of that month or the last Monday of that month, then we return true. If the month is August, then the last Monday of that month is bank holiday and we return true. And finally, if the month is in December and the day falls on Christmas or Boxing Day, we return true. And there are some edge cases where if Christmas or Boxing Day falls on the weekends, then the following Monday or Tuesday can also be a bank holiday. At the moment, this class has no tests. So what I'll do is I will create a test project for this class in order to demonstrate testing. So start by going to the Add New Project tab here. I'm going to select a project template for my test project. In this case, I'll use NUnit3. I'll name this demo.test. And the target framework will be .NET 5. The first thing I want to do is make sure that this demo test can reference the demo project, so it will have access to the method that we're trying to test. So if I go to add project reference to demo, I'll start by deleting this class that had been automatically generated for us and create a new one. So I have a fresh class here. Make it public. So in order to write tests, the NUnit framework uses an attribute called test, which then you'd sit above the method that you're trying to create. So I'll start by writing the first test for this case here, where if the date provided is on January and it's the 1st, then the isPublicHoliday method should return true. So essentially, tests are methods you write to test other methods. So what you want to do is when you write your method is to have a title that describes what the test is doing. So in our case, I'm going to write when the date provided is the first date of the year. And return true. To write our tests, we can use the arrange, act, assert pattern. What I like to do is I'll write the 3 steps comments here to help me write my test. So with the arrange here, you would write the setup steps needed in order to invoke your test. So for our date helper, we know we need to pass in a date parameter. So I'll start by writing that. And the date time that we're going to create is the 1st of January 2021. We'll also need the date helper instance in order to invoke the isPublicHoliday method. And essentially, this is all we need for the arrange step, because in the act step, we'll be invoking the isPublicHoliday and passing in the date parameter. So what I'll do is I'll create a variable called result, and I'll invoke the isPublicHoliday method and pass in the date that we've just created. So that's the act phase. The assert phase is to assert whether the outcome is what we would expect. In this case, I'm expecting the result to be true. You can pass that in. I also need to remember to include the NUnit framework. So if I open my Test Explorer now, and wait for it to run. Because of this test attribute, I should see in my test explorer this very specific test. So when the date provided is the first day of the year, then return true. So what I can do now is right click this and hit run. So I can see the test has passed. One of the things that is good to build a habit around is that if your test passed, especially the first time, you can prove that the test is working by commenting out or removing the code that you're intended to test. So if I run this, I'm actually expecting the test now to fail. This is because I commented out this code. If I've uncommented out, run it one last time, then I am confident that that line, those lines that I've just re-added, is working as expected. Okay, so now that that one's tested, we can test the next step, which is the month of May. So if the date provided falls on May, it'll go into this block. And if the date provided is the first Monday of the month, then we will return true. So this could be our next test. So I'll start by creating the test attribute again. Putting our arrange, act, and assert comments here. So to figure out the first Monday of May for 2021, I have here the calendar. And I can have a look here that the first Monday of May is the 3rd, and the last Monday of May will be the 31st. As you can see, because we've added this test attribute, the test will appear here. So I can click run on that. Again, it passes. So if I was to duplicate this test now to handle the next case, which is the last Monday of May, we know that the last Monday of May in 2021 is the 31st. If I run this, I'm also expecting this to return true. So that also passes. And again, if I wanted to check as a habit that the test is actually testing the correct block of code, I can comment this out. I'll run all of the tests again, and I'm expecting those two new tests that we've just written to fail. Likewise, when I restore them, run the test again, I'm expecting everything to pass. So you're starting to see some repetition here. So each of these tests have a very similar pattern. They all have a date that you pass in with a string. We create an instance of the date helper, and we invoke the isPublicHoliday method and then assert that is true. There is a way to reduce this repetition by using what's known as a test case in NUnit. So to demonstrate that, what I can do is I can create a new test case here. You can pass in a parameter. So this parameter could be anything we want, but for the purpose of this test, we can use the dates themselves. So if I were to do the 1st of January, just like the test above, what I can do here is within the test method, we can pass in the parameter. So you pass in the data type, in this case, it'll be a string, and I'll name this string date. What I could do is copy this exact test, and I'll pass in the string date. I can then run this. So that's passed now. This test is exactly the same as the one above here. The only difference is that the title needs to be more generic because we can start duplicating this test case and passing different parameters. So what we can do now is have one for the 3rd of May 2021 and the 31st of May 2021. And if I run this, they're all passing, but you can see that it will run the same test, but the parameter is dynamic, and therefore we can reuse this test, but passing a different parameter each time. So what that allows us to do is we can actually now delete these tests because they are being performed in the new test that we've written. The disadvantage of doing this is that we lose the context of the title of the test. So this one needs to be more generic, whereas these ones, they can provide more context. But for our usage, we can just delete all of these. So now we have this test set up, we can start adding additional test cases for the remaining months. So here, as you can see, we have August and the last Monday of that month. We can also include this in here. So now I can say August the 30th, I know is the last Monday of that month, as well as Christmas Day and Boxing Day. So if I run all of these tests, I can see that all of these tests are passing now. But if I were to comment out some of these, just to check that these are in fact passing for the right reasons. So they're failing now because I've commented out this code. If I uncomment out this code and run the test again, they all pass. Okay, so if I scroll down, there are some edge cases here for the month of December. So if Christmas Day falls on Saturday, then the statutory holidays falls on subsequent Mondays and Tuesdays. So this logic hasn't been tested yet. And in theory, I can put that date inside this same test, but I would recommend actually creating a new test for this because we can use the test title to provide the context. So what I'll do is I will write a new test case. So coincidentally, on 2021, Christmas Day would actually fall on a Saturday. So with that in mind, we can set that both the 27th and the 28th of this year will be public holidays. So if I write my test, again, I can just copy this logic. So there is some duplication here, but I think there's value in having this text here to be used as documentation almost for anyone reading this test in order to understand this very kind of specific edge case. Likewise, we can do the same for Sunday. So if I copy this test on 2022, Christmas actually falls on Sunday. So the 26th will be a bank holiday as well as 27. Another test we need to account for is when Boxing Day falls on Saturday. So when Boxing Day falls on Saturday, then the statutory holiday falls on the 28th. So I have these tests. If I run them all, you can see they will pass. Okay, so we have a whole host of tests here that should cover all of these test cases. There is one thing that is missing here. Although we have the public holidays for January, May, August, and December, I have intentionally left out the public holiday that happens during Easter. And the reason for this is I want to actually show you another process for testing. So in order to find out the public holidays for Easter, we need to figure out when Easter Sunday is. So I did a quick Google search and I found this Stack Overflow article that essentially gives us the answer to find Easter Sunday, which is this kind of algorithm here. I've already copied it down here. So we have the static method for Easter Sunday is exactly the same algorithm that you just seen. But if you look at this algorithm, it's actually very difficult to decipher what's actually going on. So one of the things we can do to prove that it works as we expect it to, we can write a test for this. So what I'll do is I will create a new file for this. Create a new file for this, and I'll call it Easter Sunday test. Make this class public. and I will give it a test case. The reason for the test case is that I can pass in the multiple dates to confirm that it works for the years that we know, or the dates that we know Easter Sunday fell on each year. So if I double check actually how the function works. So it's a static class. The method accepts a year and it returns a date time. You give it a year. So if I gave it, say, 2021, then the date time that gets returned should be Easter Sunday of that year. So what I'll do then in that case is I'll have the year 2021, and then the return value would be the 4th of April, 2021. So what I have here is the test case, and we're passing in two parameters. One is going to be an integer value, and the other is a string. And you can represent that within the arguments or parameters you provide in the test method. So in this case, the year and the expected date. So because the Easter Sunday method is a static class, I actually wouldn't need to have an arrange step for this. So what I can do is date helper dot Easter Sunday. We'll pass in the year. We'll assign this to a variable. So for the exertion step, we'll create an expected value. So pass in the expected date. Then we assert that the Easter Sunday date is equal to the expected. Right? So if I run this, the Easter Sunday test pass, to be doubly sure, what I can do is I will have other test cases that we know where Easter Sunday falls and run this. So one of the benefits of testing can be that when there's very complex algorithms or logic that can be difficult to decipher, you don't necessarily need to understand what's going on within this algorithm, but having tests for this to confirm that this works as expected will be enough to know that it works. Okay, so now that we have our Easter Sunday method available to us, before we actually implement the logic to include Easter holidays within this method, one option is to actually start writing the test first. So this process is called test-driven development. And what you do is you write the test before you implement. And the benefit of doing that is that it can help drive the logic you write when implementing this. It helps that the method already exists. So what I can do is consider the test that we plan to write. So one of the bank holidays or public holidays that happens in Easter is Good Friday. I'll start with a test case because I want to run this test against numerous years to be sure that the logic works as expected. So the first one we can write is for this year. So Good Friday happened on the 2nd of April. But it's handy to put it in here, again, for context. Alternatively, I can add it to the test case up here to reduce repetition. But for now, I'll just write it here for the purpose of what we're trying to achieve. So if I were to run this, I'm expecting this to fail. The reason is that this has not been implemented yet. Okay, so now that this test exists and is currently failing, we can start looking at implementing this. So let's say that if the month is on April. Okay, so we have the Easter Sunday method, so we can start using that. So first thing we can do is we can get the year of the date. Good Friday is the Friday before Easter Sunday. And because we know that Easter Sunday is on a Sunday, we can find Good Friday by using this logic. take away 2 days of Easter Sunday in order to find Good Friday. And we'll compare that against the date. So this logic here, Easter Sunday, take away 2 days would be Good Friday. And we're checking that the Good Friday is equal to the date provided. And if so, we want to return true. So now if I go back here and run it, the test passes. To be doubly sure, again, we can use other test cases. In fact, there's something I realized as well, that although this test case, we checked against Good Friday for this year, I just so happen to know that in 2008, Easter Sunday fell on March. So if I change that to 2008, March, the Good Friday in 2008 was actually on March the 21st. So if I were to now run this again, it will fail because of the logic. As you can see, one of the benefits of testing is that you can consider all the potential test cases available to you to determine whether the logic that you've written or the implementation is working as expected. So this is actually an edge case whereby initially, or maybe more commonly, Easter bank holidays fall on April, but there are instances where they will fall on March. So by writing this, now this particular test fails. So essentially what we have here is a bug. And to resolve this, I've written a test for that. It's currently failing. And now if I write the implementation, so if the month falls on March or it falls on April, then this logic will apply. So if I now run this, then both will pass. So as you can see, it kind of covers the potential edge case that Easter bank holidays will happen on either March or April. And then we can use our Easter Sunday method in order to find Easter Sunday and therefore find out what day is Good Friday. And likewise, we can do the same for Bank Holiday Monday. So if I were to start again, rather I'll create a new test. Again, so this is test-driven development whereby you write the test before you implement it in order to have the test ready for when you actually do implement it. You can then run your test against your new implementation, which therefore determines whether the implementation you wrote will actually work. So in order to implement this scenario within our month of March or April, we have Easter Sunday in a variable here, so we can use that in order to figure out what day is Bank Holiday Monday, which will be the next day. So if Easter Sunday, to add one day is equal to the date provided, then return true. And then I can run this. And now it passes. And likewise, I can do the same for this day, where on March, it will also be covered. And both tests pass. So I've chosen this class specifically to demonstrate the importance of tests and why they're useful, especially for this kind of method, which has many edge cases or branches, and therefore will require many tests. Testing something like this can drive your thinking and problem solving. It will encourage you to think about whether you've covered all of the bases. And as you write these tests, you might even find ways to improve the code further. For example, this class is now looking like it's doing too much, and maybe it would be a good idea to consider whether this class has too many responsibilities and whether a particular method belongs here. I won't get into that for now. It's just something to think about. Now that these tests exist, we now have room to improve this by refactoring it. So at the moment, this method is very busy. There seems to be a lot going on here, and we can improve its readability by refactoring it. So what I can do is, I've taken some time to actually refactor it. So if I paste this kind of new code here, and as you can see now, I've refactored it to use a switch statement. So we have the month here. If the case is on January, we return this method here. And within this method, all it does is it checks whether the day is on the 1st. If it is, then returns true. If not, returns false. And likewise for the other holidays here. So as you can see that this method now is a little bit more readable. If I were to run these tests again, they all still pass. So notice how I didn't need to alter the existing tests. I am very confident that this change that I've applied has not broken the existing functionality that has been applied for this is public holiday method. While the demo was quite detailed, I did forget to write a final scenario, which was for when the date provided did not fall on a public holiday. So with this, there should be full code coverage for that method. Also within NUnit, there are many other ways to assert within your test. Whichever test framework you use will be different, but will have similar levels of assertion methods. So be sure to check their official documentation. Just a quick note, even though I've refactored the code, while it's a slight improvement in terms of readability, it probably wouldn't scale very well. For example, if there is a new requirement to include public holidays for other countries, then we could run into challenges. But the point is that during the development of that feature, the test we've just written will reduce the chances of the existing functionality from breaking, and any new test you write will potentially drive the design of the new requirements. Although I use C#, Visual Studio, and .NET 5 to demonstrate testing, the core principles I've mentioned can be applied to any programming language and test framework you are using. So that's it from me, an introduction to testing using C#, Visual Studio, and .NET 5. Thank you for watching. I'll be making more programming videos like this, so please subscribe. And if you found this video helpful, please leave a like, comment, and share. Thanks again, and I'll see you in the next one.